Okay, so as you can see, this is the conventional. So if for the conventional, you don't need to write a lot of it. Okay, you may want because for last time we do the derivation, right? So after you put the assumption, you can straight away put the results. You can put the result of chi3, right? And then but for this changing of the trigonometry, you need to mention, but you need you need to mention it because this will be used in the article, right? The article do not use the P1, P2, P3. You're very careful. So, but if you want to mention, if you want to put the conventional in the thesis, can also, but as I said, you don't need to put too much. Maybe you just write some, I think this is okay. You just put the assumption here and then you straight away go to the results. But you do not show the results. Am I right? But you go to the equation, but you do not show the results. So, yeah, of course, I can see that you do not write very much. You put your P1, P2, P3, but when you put P1, P2, and P3 into the Duffy equation, do you mention the Duffy equation here? No. 3.4. Okay, you have the, so this you have to cancel. 3.4. Oh no, you don't have it. You don't have it. So and Robin, you need to reorganize your chapters. Reorganize your this is, so if you want to put the conventional, maybe you can put in the theory part for the conventional nonlinear optics. For example, you have the P1, P2, P3 like this, and then straight away you give the result of chi1, chi2, and chi3. So for chi1, chi2, and chi3 for the Duffy oscillator, because straight away you in this chapter 3, the theory, you can put the Duffy oscillators already, right? And then you said that you put this P1, P2, P3 substitution, and then you solve it, and then you find that chi1 equals to what? Chi2 is 0, right? And then chi3 you have the result. Okay, right? For the conventional one we do in the first semester, you need you don't need to put the calculation here. I mean the derivation here, but if you want, you can put into the appendix. Is it okay? Okay. Yes, right. So for example, in the direction, you need to consider things like this, right? You have to put this in the Duffy equation. You have to for the chi E1, and then you obtain the chi E1. So you put your chi E1 here. I mean the chi E1 here. And for the second order effects, you put this into your Duffy equation, and then you obtain your chi2 as 0, right? 0, right? And then for the third order effects, you put your P3 as this assumption, and then you put into the Duffy equation, then you obtain the results for the chi3, and chi3 for the fundamental frequency, Chi3 you have two results, omega and 3 omega, right? Then you just put the Chi3E for fundamental frequency. And then the derivation, if you like, you just put it in the appendix, right? Okay, yeah. Nari, what I said to Ravi is applied to you also, right?
Okay, doctor.
Yeah, right. But of course, both of you write thesis separately, yeah? Okay. And okay, so when come to Maxwell equations, you can make it into chapter 4 already, because chapter 4 is the one really mentioned by okay, this is something from the article side. Chapter 4 is the I don't know how to name your chapters. So chapter 4 is methodology and calculation. So everything related to the calculation in articles, you make it into chapter 4. Is it okay? Right. So Nari, what you mentioned here, starting from the Maxwell equation, you make it chapter 4.
So, doctor, which one?
Starting from Maxwell equation, right? Starting actually, I don't know, because both of you maybe write separately. Yeah. You may, I think both of you did mention in this article, did mention something. You can see this is our main articles. You did mention this equation 1, right?
Yes, doctor.
So anything related to this and also the Maxwell equations, you need to reorganize so that it is in chapter 4.
Oh, okay, doctor.
Okay, yeah. You need to reorganize. And then how to write it? As I said, you have to go through all the sentence. Ravin or Narin, both the same. You have to look at the sentence so that it is fit to the articles. Of course, you cannot copy the articles. But somehow you elaborate the fundamentals, the approaches. I think the Maxwell equation is relevant. Maxwell equation is relevant. So the fundamentals that you need to use for the derivation, right? So the Maxwell equation and the consideration of this wave equation, right? Okay, so this is relevant that you need to put it there. And then the equation, of course, equation of motion, of course, is the okay. This is also relevant, but maybe I don't know whether it's suitable for you to mention as equation of motion or not. It is better wave equation, nonlinear response. So you have to rename Ravin. You have to rename your subtopic. Okay. So you have to rename your subtopic. You have to rearrange your subtopics. So this is okay. This is okay. This is also okay. Right. But maybe you want to add something. Maybe you want to. Okay, you can see what I highlight. Maybe you want to put plus CC. Okay, plus CC. And then you add the half here. You add the half here, 1/2. So, well, once you mention the electric field, maybe you want to straight away use the complex notation for the real field. So this is actually the real field, but when you want to put into complex notation, you have to use a half something and then plus the conjugate, CC, complex conjugate. So here you have no problem to copy it is okay, you copy